Today we will be exploring the history, characteristics, and uses of three different series of soils across the United States.
These soils that we will be meeting today are the Superior series from the Great Lakes region, the Anvik series from the mountains of Colorado, and the Caligas series from Southern California. Let's take a closer look at each.
The Superior series is coarse loamy over clayey, mixed, active, frigid, alphic oxyaquic haplorthods, and is a part of the spottisol order. Spottisols are associated with cool, wet, and sandy areas. Superior soils have an aquic soil moisture regime, which occurs in poorly drained soils saturated with water close to the soil surface. They also have a frigid soil temperature regime, with the difference in the average summer and winter temperatures greater than 41 degrees Fahrenheit. The habitat of the superior soil is deciduous woodlands or idle croplands, and it is also found on glacial lake plains. It is neighbors with the Great Lakes Michigan and Superior, which it gets its name from.
The Anvik soil series is defined as fine loamy, mixed, superactive alphic argicryals. They are very deep, well-drained soils that formed in alluvium. Its soil moisture regime is eustic and has a mean annual soil temperature of about 42 degrees Fahrenheit. Anvik soil can be found on alluvial fans in the deep valley mountains of Colorado. These fans are formed by rushing, flowing water from a narrow chute into a less steep area. The decrease in flows allows for soil to deposit over time.
Now let's head to Southern California, where the Caligas soil series takes center stage. Officially classified as a fine loamy, mixed, superactive, thermic calcic haploxerols, this soil belongs to the mollisol order. Known for its fertility and agricultural value, the name Caligas itself is steeped in history. Derived from the Spanish term for small channels or small streams, it reflects the creek systems and water movement that shaped this landscape over time. The Caligas soil is found in Southern California's coastal plains, typically in floodplains or terraces. With a Mediterranean climate, it supports native plants and crops thanks to its fertility and good drainage.
Now here's the moment we have waited for. The three soils have entered the area and are meeting after being separated by space and time for thousands of years. The tension is palpable.
Note the distinct horizons on each soil profile. What do they mean?
The surface horizon for superior soils is an A horizon, rich in humus made from the organic matter of decomposing organisms. The next soil layer is the E horizon, which is lost minerals, clays, and organic matter, making it lighter in color and more coarse in texture than the A horizon. The next several layers are made up of varying B horizons. These horizons have an accumulation, loss, or redistribution of sesquioxides, clays, and salts, respectively. The BE horizon is distinct from the others because it is made of a combination of B and E soils. The lowest layer in the Superior series is the 2C layer, made up of the earliest parent material of clayey glacial till.
For the Anvik soil, we will start from the bottom up. Our parent material is alluvium, which forms our C layer. Above that, we have two separate BT layers that are very clay enriched. These are only separated by structure and rock percentage. Next, we have our BE layer, classified due to the presence of abundant clay formation and the evidence of leaching. Just above that is our E layer. Lots of alluviation happens here. Moving on, we can see our twin A layers. This topsoil is significantly darker than the horizons below it and has much smaller structures. Finally, we can see our beloved OI horizon, where we find most of our organic matter.
For the Caligas soil series, we will begin with the surface horizon, an A horizon that is dark in color, rich in organic matter, and highly fertile. This layer supports native vegetation and crops alike, thanks to its excellent structure and nutrient availability. Below the A horizon is the BK horizon, where calcium carbonate has accumulated. This layer reflects the soil's adaptation to the Mediterranean climate, with dry summers encouraging carbonate deposits over time. Looking back at the three soils, we can see that the number and components of their layers are very different from one another. Why did these horizons form this way?
The formation of the Superior series is associated with the retreat of glaciers thousands of years ago. The movement of the Laurentide ice sheet formed several lake basins of the Great Lakes system, and when it retreated, water from the glacier filled in these basins. It would take over 14,000 years after the glacier retreated for the Superior Series to build up and reach its current features.
As stated earlier, Andvik soil is most typically found on alluvial fans. These form when fast-moving water, often from rivers or flash floods, flows down a steep mountain or hillside and suddenly hits a flatter plain. As this water slows, it loses energy and drops its sediment load, spreading out, creating a fan-shaped deposit. Over time, multiple layers of sediment build up, creating its characteristic shape. This process is common in arid and semi-arid regions.
The formation of the Calogus soil series is linked to alluvial deposits from granite, sandstone, and shale parent materials. Over time, these soils developed in a Mediterranean climate with wet winters and dry, hot summers. Periodic flooding and sediment deposition from nearby streams, particularly in the floodplains and terraces, played a key role in shaping the soil. This process created well-drained, fertile soils with moderate to high organic matter, making them ideal for both native vegetation and agricultural use.
Look, there appears to be a rainstorm forming above the soil series. Let's see how each series handles the precipitation. Superior soils are well suited for the rain. They have a high plant-available water content of at least 25%, not counting the few rocks in the soil profile and lots of organic content on the A horizon, which further raises the PAW. Over a year, the water budget shifts from surplus to recharge and back again to surplus. It can hold so much water because of the macro and micropores in the soil texture from the sand and clay.
While not as high as 25%, the Andvik soil does have a respectable 19% plant available water. A higher rock percentage is to blame for that. Throughout the calendar year, Andvik's water budget will go from surplus, then to AET, then back to surplus. The rain is finally over. It appears that now the soil series are showing off their mainland uses to each other.
The Superior Series shows the others how it is used for recreational development and idle cropland. It is evidently proud of this, as its soils are found on islands in the Apostle Islands National Lakeshore.
Andvik soil is almost exclusively used as a natural habitat for wildlife. Because it was formed in the wake of water movement, it can provide quite the oasis for critters. For humans, we can sometimes find logging operations on Andvik soils, as it is known to foster growth for massive pine trees.
The Calogus soil series is primarily used for agriculture, particularly for growing crops like citrus fruits, vegetables, and wine grapes, thanks to its good drainage and fertility. This soil is also ideal for urban development, landscaping, and recreational areas, supporting turf grass and ornamental plants with ease. The three soils are seemingly fighting over which has the best land uses. We can see each storm off and head back to their habitats. It seems that their meeting is over.